So far we have learned already about Newton's first law and Newton's second law. So Newton's first law says that it's the law of inertia. So every body that is at rest will stay at rest, or every body that is in motion will stay in motion unless a non-zero force is acted upon it. Okay? The second law says that the sum of all forces acting on an object causes a certain mass to accelerate at a certain rate. So the sum of all forces equals mass times acceleration. So in this video, we're going to be learning about Newton's third law. And Newton's third law is that it's the reaction. So for every action, there's an equal and opposite reaction. You've probably heard this before. So Newton's third says that when one object exerts a force on another, there is an equal and opposite force from the second object on the first. Okay, so this makes a lot of sense. If I were to push into the surface of the paper here with 10 newtons, that means the paper pushes back at me with 10 newtons. Okay. Also think about in terms of rowing a boat. Okay. So if someone is sitting in a boat, right, and they have a paddle, and I'm a horrible artist, right, and they're standing in the boat, right, and they have an oar, okay, they cause a force, they force the oar to push against the water, and then the water pushes back, which makes the boat go forward. Okay. Another example of this is propulsion. Propulsion. So if I were to have a spaceship here, and again, my drawing skills are lacking, and this spaceship is firing off some gas that is pushing down this way, that means that then the gas is pushing on the shuttle, forcing it to go this way. So that's how propulsion works as well. Okay? Now, I'm also going to talk to you today, we're going to learn about friction. Okay? So friction is another case of Newton's second law. And we're going to derive some equations for friction. Friction is really intuitive, okay? So let's just go ahead and look at an example. Let's say I have this ball and I roll it, okay? Or I have this and I push it, okay? What has more friction, okay? The block, right? So we have sliding friction versus rolling friction, okay? We say that rolling friction is essentially zero. It's almost zero, okay? So approximately zero. Sliding friction is really the kind of friction that we're going to be calculating and working with here in class. So for our purposes, we can sort of assume that anytime something is rolling, we can say that the friction is almost negligible, okay? So sliding friction we specifically call kinetic friction. Okay, so let's look at an example where we have then two different types of surfaces. Okay, so here I have some sandpaper, and here I have some nice smooth white paper, right? So if I were to push this along, right, along the nice smooth paper, and then I push it on the sandpaper, right, barely goes at all. So, sliding friction, we know that friction must have something to do with the property of the surface. Okay, so it is the property of the surface that can affect the amount of friction, okay, or both surfaces as they run past each other. In terms of the equation, this is called the coefficient of friction. Okay, and we write it with the Greek letter mu. Okay, and if we're talking about kinetic friction, we put a little k, and we'll see in a second here another kind of friction, static friction, which we then would put an S there. Okay, so it is a coefficient of friction. It's the property of the surface. So it will either be given to you for that specific type of surface, or it will be calculated for that surface. But it's a property of the surface. It doesn't change during the problem. It's sort of a constant based on whatever scenario that you're going to have, right? Now the other thing is, let's look at if I have this brick, and let me just grab something else that's a little bit smaller. Okay, let me get my drawer here. Okay, here I have this. Okay, now you can't really see, but this thing weighs about like 50 grams, and this thing is about 200 grams. Okay, so if I were to apply the same force and sort of push, you can see that there is a difference in the amount of friction. Okay, the reason is this thing is heavier, right? It's sort of like pushing into the surface more, and so it's harder for it to slide. Okay, so there has to be something about the contact between the two surfaces that affects the friction. Okay, so again, this one is heavier than this one, but if I were to push down and try and slide, the friction increases as well. So really what is affecting it is that contact force, and that contact force we call the normal force. So again, we have force normal that affects, okay, so how hard you are pushing into the surface. So hard pushing into the surface. Okay, so these are the two things that affect friction. So let's think about them and mathematically figure out the equation. Okay, so we're going to have the force due to friction equal to some algebraic relationship between these two factors. Okay, so we have to think about whether or not is it going to be a inversely proportional or directly proportional. So are we going to multiply these two terms, or are we going to divide these two terms? So let's think about it. If force normal increases, right, so if it's greater, if I push into something harder, right, friction will go up. So I'm going to put force normal right here. Okay. Now, for the coefficient of friction, okay, if the coefficient of friction is larger, so there's more of a friction between the surfaces, then the friction will also increase. So we end up with the equation force friction is equal to a property of the surface times force normal. So this is the equation for kinetic friction when we have something sliding. Okay. Now, friction doesn't only occur when something is moving, right? So if I have this sitting here and I push, right, so I'm applying some force to it, it's not going anywhere. And we know that friction is causing it not to move, right? That must be the opposing force that's keeping this thing from accelerating across the paper. This is called static friction. Okay, so static friction is when there's no motion. Okay, so there's no movement. Kinetic friction is when we're sliding. Now, the equation for static friction is very similar to the equation for kinetic friction. However, let's kind of look, let me use the sandpaper example here. So if I put this block on the sandpaper, actually let me use the heavier one. If I put this on the sandpaper and I push with maybe a 10 Newton force. It doesn't go anywhere, right? 20 Newton force doesn't go anywhere. 30 Newton force doesn't go anywhere. And then all of a sudden 40 Newton force and it starts to move. Okay? So in this case, the force due to friction, which we'll say static friction, we'll put a little S there, we'll put a little K here for kinetic, is less than or equal to the coefficient of static friction times the normal force. Okay? And the reason why we have that less than or equal to is if I have this thing sitting here, right, if I push with 10 newtons, then the force due to friction must be 10 newtons. If I push with 20 newtons, then the force due to friction must be 20 newtons. So this number is variable, okay? Now, let's talk about the difference between the coefficient of static friction and the coefficient of kinetic friction, okay? So think about if you were to move a couch in your living room and it's carpeted. If you were to push the couch, at first it takes a lot of force to sort of get it going, but once it's moving, it's a lot easier to sort of keep it going, right? So we can say something to compare the static friction between like the couch and the carpet, and the kinetic friction between the couch and the carpet. Okay, so the coefficient of static friction is always greater than the coefficient of kinetic friction because it's easier to keep something going than it is to get it going. Okay, so that's all very intuitive stuff. Okay, let me go ahead and just do a sample problem. Okay, let's do the couch problem. So let's say I have a couch, right, and I'm pushing with some applied force of 100 newtons, and I'm going at a constant velocity. So my acceleration is equal to 0. What is my kinetic friction? So what is my kinetic friction? Okay, so I could easily answer this question. It has to be 100 newtons, right? Because if I'm going at an acceleration of 0, my net force has to be 0. Okay, now let's say that that couch weighs 350 kilograms. Let's figure out what the coefficient of kinetic friction is between the couch and the carpet. Okay, so I know that my force of kinetic friction is 100 newtons. Okay, so I've got Fk is equal to mu k Fn. So we'll just plug in 100 is equal to mu k. That's what I'm trying to solve. And now let's talk about the normal force. So we're just sitting on the ground here, and let's say that you're pushing exactly horizontally, so you're not pushing into the ground at all. In this case, your Fg will be equivalent to your Fn. So we could say that 100 equals mu k mg, okay, which 100 is equal to mu k 350 so times 10, so that would be 3,500 newtons. Okay, so your coefficient of kinetic friction would be equal to 0.03. Now, it is unitless because this is a newton and this is a newton, so when you divide, the newtons cancel. Okay. We'll also be doing a lot more sample problems. We'll do some static friction problems, some problems with acceleration in some classwork.